If you tried to point to the center of the universe, you would fail. No matter where you stand, no matter how far you travel, there is no place you could point to and say, "This is the middle of everything." This isn't because the center is hidden. It's not because we haven't looked far enough. It's because the idea of a center doesn't apply to the universe at all. The universe has no center, no edge, no special point where everything began. Look up at the night sky. If you're somewhere dark enough away from city lights, you'll see thousands of stars. They seem to spread out in all directions, above you, around you, stretching to the horizon in every direction you look. It's natural to wonder where the center of all this is. Where did everything begin? Where is the middle of the universe? If the universe is everything that exists, it feels like there should be a center somewhere, a place that is more central than everywhere else. But here's something beautiful and strange. The universe has no center, not because we haven't found it yet, but because the very concept of a center doesn't apply to the universe. There is no middle, no edge, no central point from which everything expands. This might seem impossible. How can something have no center? Everything we know has a center. A circle has a center. A sphere has a center. Even Earth has a center, deep beneath your feet. So how can the universe, which contains everything, have no center at all? Tonight we're going to explore this mystery together, slowly, calmly. We're going to understand why the universe is so different from everything we're used to, and we're going to see how this changes the way we think about our place in existence. Let's start with something simple, something familiar. Imagine a balloon, not inflated yet, just a deflated piece of rubber. Now imagine you take a marker and draw dots all over the surface of this balloon. Lots of dots, scattered everywhere. Now you start to inflate the balloon, slowly, steadily. As the balloon expands, what happens to the dots? They move apart from each other. Every dot gets farther from every other dot. If you were an ant standing on one of those dots, you would see all the other dots moving away from you, in all directions. Here's the interesting part. It doesn't matter which dot you're standing on. Every single dot sees the same thing. All the other dots moving away. Every dot could think, "I must be at the center, because everything is moving away from me." But there is no center. Not on the surface of the balloon. The surface is expanding, yes, but there's no point on the surface that's more central than any other point. Every point is equivalent. Every point sees the same expansion. This is similar to how the universe works, but with one important difference. With the balloon, we can imagine the center being inside the balloon, in three-dimensional space. But the universe isn't expanding into anything. There is no outside the universe. There is no higher dimension where the center could be. The universe is all there is. This is hard to imagine. Our brains evolved to understand three-dimensional space. We're very good at it. We can picture objects. We can imagine their centers. We can think about what's inside and what's outside. But the universe doesn't work like the objects we're used to. Let's think about this differently. Let's think about what we actually observe when we look at the universe. When astronomers look at distant galaxies, they notice something remarkable. Almost every galaxy is moving away from us. The farther away a galaxy is, the faster it's moving away. This was discovered about 100 years ago by an astronomer named Edwin Hubble. He measured the light from distant galaxies and found that it was shifted toward the red end of the spectrum. This red shift happens when something is moving away from you, like the change in pitch of a siren as an ambulance drives past. When it's moving away, the pitch drops. The sound waves get stretched out. Light does the same thing. When a galaxy moves away from us, its light gets stretched. The waves become longer, and longer waves are redder. So we see redshift, and the amount of redshift tells us how fast the galaxy is moving away. Hubble found that distant galaxies weren't just moving away. They were moving away at speeds proportional to their distance. Galaxies twice as far away were moving twice as fast. Galaxies 3 times as far away were moving 3 times as fast. This is called Hubble's law. Now, when you first hear this, it sounds like we must be at the center. Everything is moving away from us. We must be in the middle, with everything else rushing outward from our location. But that's not what's happening. Remember the balloon. Every dot on the balloon sees all the other dots moving away. And the farther away another dot is, the faster it appears to be receding. Not because any dot is at the center, but because the space itself is expanding. This is what's happening with the universe. Space itself is expanding. Galaxies aren't moving through space away from us. Space is expanding between us and them, and this expansion looks the same from every point, from every galaxy. Every observer sees all the other galaxies moving away. Every observer could think they're at the center, but none of them are. There is no center. There is only expansion everywhere, all at once. Let's pause here for a moment. Let this idea settle. The universe is expanding, not into anything, not from any central point, just expanding. Space itself getting larger, carrying galaxies along with it. This happens everywhere, at every point in space, all simultaneously. This is one of the most profound discoveries in human history, and it's also one of the most peaceful things to contemplate, because it means we're not at the center. But it also means we're not at the edge. We're not in some special location. We're just here, in a universe that looks the same from every perspective. Now let's think about what this expansion means for the history of the universe. If the universe is expanding now, that means it was smaller in the past. Galaxies that are far apart now were closer together yesterday, even closer together the day before that, even closer 1,000,000 years ago. Keep going back in time, farther and farther. Eventually, you reach a point where everything was very close together. All the matter and energy in the universe compressed into a very small space. Very hot, very dense. This is what we call the Big Bang. Not an explosion in space, but an expansion of space. About 13.8 billion years ago, the universe was incredibly small and hot. Then it began expanding, and it's been expanding ever since. But here's the important part. The Big Bang didn't happen at a point. It didn't happen at some location in space. It happened everywhere. Because everywhere that exists now was compressed together then. Every point in space has existed since the beginning. Every point was there at the Big Bang. This is hard to visualize. We're used to thinking of explosions as happening at a point and spreading outward. A firework explodes at one location and debris flies away from that point. But the Big Bang wasn't like that. It was an expansion of space itself. And since space is everywhere, the Big Bang happened everywhere. If you could travel back in time to the moment of the Big Bang, you wouldn't find a location where it happened. You would find that everywhere you look, the universe was hot and dense. There was no outside, no surrounding space, just the universe itself. Small, hot, dense, everywhere. Then expansion began. Space grew larger. Matter and energy spread out. Temperature dropped. Over billions of years, this expanding, cooling universe formed atoms, then stars, then galaxies, then planets, then you, here, now, reading these words. And this all happened without a center, without an edge, without a preferred location. It happened everywhere at once. And it's still happening. Right now, the universe is still expanding. Space is still growing. Galaxies are still moving apart. But you don't feel this expansion. The expansion of space only matters at very large scales. The distance between galaxies. At smaller scales, other forces are stronger. Gravity holds planets in orbit around stars. It holds stars together in galaxies. It holds atoms together in your body. The expansion of space is real, but it's gentle, slow on human timescales. You could think of it as a background effect, always present, always happening, but overpowered by other forces in your daily life. Let's think about another question. If the universe has no center, does it have an edge? Is there a boundary? A place where the universe ends and something else begins? The honest answer is, we don't know. We can only see a limited portion of the universe. This is called the observable universe. It's the part of the universe from which light has had time to reach us since the Big Bang. Remember, the universe is about 13.8 billion years old. Light travels at a fixed speed, very fast, but still finite. So we can only see light from objects that are close enough that their light has had time to reach us. This creates a horizon, not a physical edge, but an observational limit. Beyond a certain distance, we simply can't see anything. Not because there's nothing there, but because light from those regions hasn't reached us yet. The observable universe is about 93 billion light-years across. That's very large. Much larger than 13.8 billion light-years, which you might expect. The reason is expansion. While light was traveling toward us, space was expanding. So objects that emitted light 13.8 billion years ago are now much farther away than 13.8 billion light-years. But this observable universe is just what we can see. The actual universe is almost certainly larger, possibly much larger. It might even be infinite. We don't know. If the universe is finite, it probably doesn't have an edge in the way you might imagine. It's more likely to curve back on itself, like the surface of a sphere. A sphere's surface is finite. It has a specific area, but it has no edge. If you travel in one direction on a sphere's surface, you eventually come back to where you started. You never reach a boundary. The universe might be like this, but in 3 dimensions instead of 2. It might curve in a way that's hard for us to visualize, a way where you could travel in a straight line and eventually return to your starting point, never encountering an edge, never leaving the universe, just traveling through curved space. Or the universe might be infinite, stretching on forever in all directions. No edge, because there's always more space beyond any point you can imagine. This is also possible. We simply don't know which is true, but either way there's no center. A finite curved universe has no center, just like a sphere's surface has no center. And an infinite universe has no center because every point could equally claim to be the middle of infinity. Let's rest with this for a moment. Let's just be here, thinking about this strange and beautiful fact. The universe has no center. You are not at the center. But you're also not far from the center, because there is no center. Every point is equivalent. Every location sees the same large-scale structure, the same expansion, the same laws of physics. This is called the cosmological principle, the idea that the universe looks roughly the same from every point. Of course, there are local differences, different galaxies, different structures, but on the largest scales, the universe is homogeneous, uniform, the same everywhere. This principle has profound implications. It means the laws of physics that work here also work in distant galaxies. The same atoms, the same forces, the same fundamental constants. We can study the universe by studying what's nearby, confident that what we learn applies everywhere. It also means we're not special. Our location isn't special. Our galaxy isn't at the center of anything. We're just here. One galaxy among hundreds of billions, orbiting one star among hundreds of billions in our galaxy. On one planet among trillions in the universe. This might seem humbling, and it is, but it's also strangely comforting. We don't have to be at the center to matter. We don't have to be in a special location to be real, to be important, to have value. We're just here, part of this vast, centerless universe, and that's enough. Let's think about what it means to exist in a universe with no center. What does this tell us about reality? About existence? About our place in the cosmos? First, it tells us that the universe is more subtle than our everyday intuitions suggest. We're used to things having centers, having edges, having clear boundaries, but the universe transcends these familiar concepts. It operates on principles that are harder to visualize but no less real. Second, it tells us that position is relative. There's no absolute position in the universe, no cosmic coordinate system with a true origin. Every point is just defined by its relationship to other points. You are here. Some things are closer to you, some things are farther away, but there's no absolute measure of where here is. This relativity of position connects to Einstein's theory of relativity. In relativity, there's no absolute space, no absolute time. Everything is relative to the observer. What looks stationary to you looks moving to someone else. What seems simultaneous to you happens at different times for someone moving relative to you. The lack of a cosmic center fits perfectly into this framework, because if there were a center, that would define an absolute position, an absolute frame of reference. But relativity tells us there is no such thing. Every frame of reference is equally valid. Every observer has an equally valid perspective on reality. Third, the centerless universe tells us something about infinity. We tend to think of infinity as something far away, something at the edge of things. But if the universe is infinite, then infinity isn't far away. It's right here, because every point in an infinite universe is equally surrounded by infinite space. You don't have to travel to reach infinity. You're already immersed in it, already part of it, already surrounded by it in all directions. This is a profound thought. Infinity isn't elsewhere. It's here, now, all around you. Fourth, the expansion of space gives us a deep connection to the past. Every point in space carries the history of the universe. The Big Bang didn't happen somewhere else. It happened here, where you are now. This very location was there at the beginning, was part of that hot, dense state, has been expanding ever since. You are made of atoms that were forged in stars. Those stars formed from gas clouds. Those clouds formed from the cooling matter of the early universe. That matter emerged from the Big Bang, which happened right here. Among other places, everywhere, this gives us a direct connection to the deepest past. You're not separate from the history of the universe. You're made from it, composed of it. A continuation of processes that began 13.8 billion years ago. Not elsewhere, but here, in the very space you occupy now. Let's think about practical implications. How does knowing the universe has no center change anything? Does it matter for our daily lives? In one sense, it doesn't change anything practical. The Earth still orbits the sun, the seasons still change. Your life continues as before. The lack of a cosmic center doesn't affect how you make breakfast or go to work or spend time with people you love. But in another sense, it changes everything. because it changes how you think about your place in existence. It removes the question of whether you're at the center or the edge. Neither concept applies. You're simply here. In a universe where here is equivalent to everywhere else, this can be liberating. You don't need to be at the center to matter. You don't need to be in some cosmically special location to have meaning. You can find meaning right where you are, because where you are is as valid as anywhere else in the universe. It also connects you to the whole. You're not separate from the universe. You're part of its structure, part of its expansion, part of its history, made from its matter, governed by its laws, existing in its space. This connection is real, physical, not metaphorical. The atoms in your body came from stars. The energy in your cells came ultimately from the Big Bang. The space you occupy is part of the expanding fabric of the universe itself. Understanding this can create a sense of belonging, of being at home in the universe, not because you're at the center, but because you're part of the whole. And the whole has no center, so every part is equally valid, equally real, equally connected to everything else. Let's also think about observation. When you look at the night sky, you're seeing the universe from your perspective, from here, from now. Every point you can see is at some distance from you. Some points are close, some are far, but none of them are more central than you are. If you could instantly transport yourself to a distant galaxy, billions of light years away, what would you see? You would see a similar view. Stars and galaxies spreading out in all directions. Our galaxy would be far away, just another small point of light. That distant galaxy would seem to be at the center of everything you could see, but it wouldn't actually be at the center, because there is no center. Every observer sees themselves as seemingly central, not because they are, but because observation creates a local perspective. You can only see out from where you are. So naturally you appear to be in the middle of what you can see, but this is just perspective, not cosmic reality. This is similar to how Earth appears flat when you're standing on it. Locally, it looks like you're at the center of a flat plane, but this is just limited perspective. The actual shape of Earth is spherical, no center on the surface. Your local perspective doesn't reflect the global truth. The same with the universe. Locally, you might seem central, but globally there is no center. Your perspective is valid, real, but limited. The whole truth is bigger than what you can see from any single point. Let's breathe with this for a moment. Let's rest in the understanding that we're here, in a vast universe. A universe with no center, no edge we can reach, no preferred location. Just space, expanding, filled with matter and energy, governed by simple laws, the same laws everywhere. This universe gave rise to stars, to planets, to chemistry, to life, to consciousness, to you, here, now, thinking about the universe, being aware of your place in it, or rather, your non-place, your equal with everything else location in a centerless cosmos. There's something peaceful about this, something that removes pressure. You don't have to be at the center to be real, to be valuable, to be part of something vast and beautiful. You already are, just by being here, just by existing, just by being part of this strange, wonderful, centerless universe. The universe doesn't care where its center is, because it doesn't have one. It doesn't need one. It exists perfectly well as it is, expanding, evolving, creating, sustaining, all without reference to any central point. And you exist in it, made from it, part of it, not at the center, not at the edge, just here, which is exactly where you need to be. Because here is where you are. And where you are is real, is valid, is connected to everything else that exists. This is the beauty of a centerless universe. It makes every location equal, every point valid, every perspective real. You don't need to be anywhere else. You don't need to be more central. You just need to be here, present, aware, part of this vast, expanding, centerless cosmos. Thank you for spending this time thinking about the universe, about infinity, about expansion, about the strange and beautiful fact that everything exists without needing a center. May you rest well. May you feel at home in this centerless universe. May you find peace in knowing that you're exactly where you should be. Not because this location is special, but because every location is equally valid, equally real, equally part of the whole. The universe has no center, and that means you belong here, right here, always here, in this perfect, centerless now. Rest well.